In this screencast, we are going to talk about how to synthesize alkynes. So just as a quick refresher, we have talked a lot about how to synthesize alkenes using one elimination reaction, and that forms one pi bond. In this screencast, we're going to talk about how to synthesize alkynes, which are triple bonds. They have two pi bonds, and we can do this if we use two elimination reactions. So, and we do two consecutive elimination reactions here. Now, for this to work, you can do this from two different starting materials. The first starting material that you can use is a Vicinal Dihalide, and that is shown in 1 above, and this basically just has two halogen atoms on adjacent carbons. And so when we look at this, these are shown in blue. There's a halogen atom here on one carbon, right? And then there's a halogen atom here on the other carbon, and they are right next to each other. So you have one elimination where in this elimination, this is your alpha carbon and this is your beta carbon. And so the NH2 comes and it grabs that proton, and those electrons go there to create a double bond, and the chlorine leaves, right? Then we have another beta elimination where now this is your alpha carbon and this is your beta carbon, and the base comes in and removes that proton. Those electrons go down there to form a triple bond, and this halogen leaves, and there's our triple bond. Now this can also work with a geminal dihalide. And a geminal dihalide just has two halogen atoms on the same carbon, right? So what do I mean by that? We have one carbon here, and we have the two hydrogens, and then we have this carbon here, and they have the two halogens. So in this reaction, this would be the alpha carbon, and this would be the beta carbon, right? And the NH2 would come, it would remove a proton, those electrons would go there to form a double bond, and one of the halogens would leave. Then the NH2 would come in again, and again, this would be the alpha carbon, and this would be the beta carbon, and it would remove a proton here. These electrons would go here to form a triple bond, and that halogen would leave. And so these are two ways we can synthesize alkynes. Now, I want to talk for just a moment about the bases required for this. Stronger bases are needed to synthesize the alkynes than alkenes. Right? So typical bases are things like an amide, so for example, NaNH2 right there. Now, do not confuse this with the amide functional group, right? This is sodium amide. It is, it's different than an amide functional group. So just kind of FYI, don't confuse that. The other thing that can be used and is used pretty frequently is Ch08, which is a butoxide. That can also be used with DMSO as the solvent, right? And so stronger bases are just needed to break the stronger sp2 hybridized carbon-hydrogen bonds in that second elimination reaction. Now, I want us to look at a specific example. So, for example, right, if we look at this particular molecule where we have the two chlorines on the same carbon, This would be an example of a geminal dihalide. And what we see is when you're using that sodium amide, you're going to use, or a lot of times it's shown as 2 equivalents, or it's shown as excess, okay? And so then we get 2 new pi bonds here. This is an example of a vicinal dibromide where we're using excess tert butoxide here in DMSO, and we also end up with a pi bond. So I like to show these examples because you can see here how the amounts are given differently above the reaction, and I just don't want that to throw you off if you see that in a homework problem. This is it for forming alkenes or alkynes. It's a really short screencast. If you have any questions, please feel free to reach out.